Okay, so for today we're going to move on from timers to counter instructions. Obviously the timers are kind of an advanced function as you guys are starting to discover in the lab. The timers allow us to create things like a traffic signal light. The timers allow us to run a process for a given amount of time. Timers allow us to control things like irrigation systems. But unfortunately the timers aren't going to cover everything we need to do with that PLC. Okay? One of the vital functions, and probably your two most vital functions when dealing with the PLC, are the timers and counters, because of all the things that they can replace that are hardwired. Okay, unlike the timer, the counter This is kind of my brief definition of what the counter does. The one we're going to spend the majority of the time talking about is the up-down counter. And what the up-down counter does is it counts product, or it could count cycles, and it'll energize its bit according to the user parameters that we use. What did we always say about user parameters? Yeah, we're going to draw them in blue on the board because it shows up better, but what color are they inside the program? Green. They're typically green. The green pins are your user parameters. So product counts could be, let's say I have a proximity sensor and I have cans, metal cans that are coming past that proximity sensor on a conveyor belt. Every time I get that 12th can, I package a 12 pack. Every time I get that 24th can, I package a 24 pack. And maybe I can select between what I'm packaging. Or perhaps maybe I'm just doing a total product count. Maybe the manager of the plant wants to know how many of this widget he has made in a given day. Maybe the goal is to produce 1,000 of these machines a day, or 1,000 of these circuit cards a day, or 1,000 of these molded plastic pieces a day, or whatever it is. What I can do then is I can use a counter to actually count how many of those things have come past that point in the system, and that means how many are going to be put onto a pallet at the end of the line, or how many are going to end up in this box at the end of the day. So the manager could just log in to that PLC from anywhere in the world and look at that product count. Okay. Cycles I was talking about there. Let's say I'm running a motor, okay, or an assembly line. Every time I start that system up, maybe I want to count that as a cycle. And maybe once I've cycled this system 1,000 times, I want to do maintenance on it. Okay, or maybe when this motor has been energized and de-energized 1,000 times, maybe I need to grease some bearings somewhere or something like that. So that could be cycles or products. There's lots of different things you guys can count. As you'll discover in the future, is you could also count timing bits. So I could have feeding the counter an asynchronous pulse. Remember we did the asynchronous pulse timer. And I could have one timer that counts 5 1 pulse per second cycles, and maybe that would turn on my buzzer or turn something off, whatever it could be. So lots of different things that you can use these counters with. Definitely designed to be utilized in conjunction with your timers though. Alright, the pins that you see on your counter here. The R pin is your reset. The CMT pin, what do you suppose that is?
Count.
Yeah, that's your count pin. And what's DIR?
Direction.
That's your direction pin. Does anybody need this stuff that I wrote for the definition here? You guys good on that? Okay. And then that blue pin down at the bottom, what is the blue pin?
User parameters.
Those are your user parameters over here. Okay, so I have 4 pins, of which I can only physically hook up to 3 of those pins. Only the black pins are going to allow me to actually physically hook something up, an input or another output or a timer bit or anything like that. The blue pin is going to be my on and off threshold. My on and off threshold is just a variable. Okay, so what might I put in there as an on threshold?
many times the system goes off.
Yeah, how many times before that counter bit energizes? So maybe on the 10th time, or let's change that. Let's make it the 12th. I'm packaging 12 packs of some sort of soda pop or something, right? When I get to 12 cans, I want to actuate some other machine, all right? The off threshold, typically the off threshold, well, the logo's kind of strange in the off threshold side. The off threshold, this one here, the on threshold is a greater than or equal to, okay? So in order for the C001 bit, when I say C001 bit, I'm talking about a contact that's labeled C001, right? In order for that bit to be on, I have to be greater than or equal to 12. So when I count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it'll turn on right at 12. At 13, what will it be? It'll be on. 14, it'll be on. Anything greater than 12, it'll be on. The one thing that's a little bit strange about the logo is the off threshold. The off threshold is only less than that number, okay? It will not turn off at the off threshold number. It'll turn off at one less than that number. So you get into a little bit of trouble if you put the number 0 in there. Why?
Wouldn't work.
Yeah, it wouldn't work because I'd have to get to a negative number to be less than that. So typically, I like to use 1 in there as my off threshold. So anytime I'm at 0, it will turn off. Now it could be that you have 12 in there. If I had 12 in there, and I'm going in the upward direction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it would turn on. And then when would it turn off? Anytime I got to 11 or below, right? So anytime I was less than 12. Just to give you a little bit of an idea, I'll show you a little kind of a step diagram over here, how it's going to work here. All right, so I typically, if I'm not sure what to use in the off threshold, if I know that I want it off when it's reset or when it's set to 0, I want to make sure that's at 1. Okay, that way whenever I reset this counter using the reset pin, that reset's going to plug a 0 into the current count. And when it plugs that 0 into that current count, what's it going to do? It's going to reset that bit. Exactly right. If I had this at a 0 and I energized the reset pin, it wouldn't reset the bit, okay, because it'd be equal to the off threshold. And we know it needs to be less than that off threshold. So that's the one thing that's a little strange. The way I like to do the counters is I like to talk about the bits over here and then look at an output. So when we look at the output, we're gonna put Q1, okay? The C001 bit is going to energize Q1, is what we're going to look at. I'll do a little diagram over on this side of the screen. All right, so there's 3 pins that we're concerned with. One of the pins is my reset pin. And my cameraman's going to kind of have to follow a little bit here. Reset, my count pin. And these are in the order. I'm going to put them on the board in the order that they're actually on that functional block. And my last pin is my direction pin. And then let's go ahead and talk about what we're going to energize. We'll say we had the C001 bit. And when I say bit, I'm talking about a normally open contact that's addressed to C001. Okay? That's what that means. And you could write that in there if you wanted to. The Q1, we don't even need to include the Q1 at this point. The C001 bit, anytime that's on, it would be energizing something, right? Could be energizing an output, could be energizing a timer, could be energizing anything. So we know that we can use that C001 bit. That's all I'm looking for there. But then we need our parameters. Let's talk about our parameters. Let's say our on threshold, I'm going to set that user parameter for the on threshold equal to 12. And let's set the off threshold equal to 1, like we talked about already, right? Now what I like to do is I like to kind of look at what's happening. I also want to, maybe up here, keep track of the current count. Okay, so initially, when I power this device up, initially the current count's going to be at what?
0.
Yeah, it's typically going to be at 0, okay? So I'm starting off with my current count at 0. All right? And let's say for these I'm going to have a logical 0 or a logical 1. Okay, so for each one of these, I can be a 0 state or a 1 state. And for the reset, right now I'm off. Okay? So I'm going to draw little square waves. If I did this, what would that mean? I would turn my reset on. And then if I did this, it would be off, right? So you guys see how that's kind of going there. So right now my reset's at 0. And let's make my count pin at 0. Alright? And my direction pin, one thing I'll remind you about on the direction, I gotta look myself. For the direction pin, this is something we haven't talked about yet. We'll just mention it, then we'll get back into this. For the direction pin, a 0 on the direction pin means to increment. A 1 on the direction pin means to decrement. What do I mean there? Yeah. Means that if my direction pin is set to high, every time I engage the count pin, it's going to go down. My direction pin is set to low, every time I engage the count pin, it's going to go up. Okay, so it can either count up or down. That's where the name comes from, an up-down counter, right? All right. So the direction pin 0 means that the counter is an incrementing counter. The direction pin of 1 means that it's a decrementing counter. Could I switch that partway through? Sure, I could switch that partway through. Imagine that you have this counter set up on a parking ramp, which is one of the jobs you'll do in here. And let's say that that parking ramp is going to keep track of how many cars or how many spaces are available in that parking ramp. So every time a car comes in, I want to increment the count, very good. And every time a car leaves on the other side, I want to decrement the count, exactly right. And then I could take a big 7-second display, and I could display how many spots are remaining in that ramp, right? Okay, it could be 83, and every time that count goes up, there's one less spot in the ramp. Every time that count goes down, there's one more spot in the ramp. Anybody ever seen that before? Downtown St. Paul has tons of these. Okay, if you go drive downtown St. Paul down West 7th Street or down Wabasha or Kellogg, you'll find that they'll have big signs. The signs will say, yeah, the Kellogg Street ramp has 36 spots remaining. The River Center ramp has 1,000 spots remaining. And what that does is it kind of routes people. You know, because of the skyway systems that we have here in Minnesota, it doesn't really matter which ramp I park in. I want to park in a ramp that's fairly close to work, but I don't want to drive up to a ramp that's full. If I can't find a spot, it doesn't do me any good. So they actually display some of those. Okay, so right now I'm going to start incrementing. So if I'm going to be incrementing, I'm going to have my direction pin. This will be 0, 1 also. Oops. This will be 0, 1. So initially my direction pin is going to be set to low. So right now everything is set to low. Okay? And therefore my C001 bit is what right now? It's off. It's a 0. Okay? Now what we're going to do is we're going to leave. We're just going to keep kind of moving on here. I won't draw a line here, but let's go ahead and let's take our count right here up. Let's pulsate it one time. As soon as I pulsate that count bit, let's assume that my reset is held low, my direction is held low. Okay? What's my current count going to do? It's going to go up by 1, right? So this leading edge triggered my current count to increment by 1. The reason why it incremented was because my direction pin right now is set to low. Okay? So again, if you're looking at the counter itself, C001, what you'd see is whatever bit is triggering reset would be off. Whatever bit was triggering count right now, that pin would be true right now. That's what made me increment. Okay, that could be addressed to an I1 with a switch, right? that could be addressed to an I1 with a proximity sensor or anything like that. And right now my direction pin would be low. So you're actually seeing what's happening here. That's what's going to be going on inside the PLC when I flip that switch on. I take that count pin high, that gives me a logical 1 on that count pin. Alright? Now if I hold that count pin high, if I were to just hold it high, it would just stay at a 1. It only does it on a 0 to 1 transition. So what do I get? I get 1 count per 0 to 1 transition. On the count pin. I shouldn't be drawn sideways here. So I'm only going to get 1 count per 0 to 1 transition on the count pin. So if I leave it high, it's just going to stay at that incremented count by 1. So if I was at 2 and I went to high, it would go to 3. And if I left that switch on forever, it would just stay at 3. Alright? It's going to take a pulsating signal for it to change. Alright? 1 count per 0 to 1 transition on the count pin. Alright. I'm going to erase that unless anybody need that.
And again, that pulse comes from that proximity sensor you had set up.
Yep. In this case, I could be using the proximity sensor that's counting cans. And my goal is to count 12 cans. That would work perfect. Absolutely. Could be anything though, right?
Yeah.
It could be my system run bit. My system run bit, my M1 contact, could be feeding that counter. And I'm tracking how many times the system has been energized and de-energized. Energized, every time it gets energized, it's going to count by 1, right? Every time that M1 bit turns on. And when it turns off, it's going to get ready to count another 1. So that's what it's going to do. All right. All right, so let's keep moving on then. Let's talk about what's going to happen next. The next thing that's going to happen is I'm going to go back low. What's my current count going to do? It's going to stay the same, right? And let's assume that everything else has stayed low. My C001 bit is still off. What if I pulsate this again? What's going to happen?
Go to 2.
It's going to go to 2. And I'm not going to show the gap in between this time, but what if I pulsate it again? It's going to go to 3. And again. 4. And again. 5. And again, I'm assuming that these are staying low, right? I'm assuming that everything else is low right now. And we can go on for days here, but let's just jump ahead in time here. Let's put ourselves at 11. Okay? So this next pulse gave me 11. Now as soon as I get to 12, what's going to happen?
Open up.
The C001 bit, as soon as I get to 12, the C001 bit becomes a logical 1. And I'm not going to change it yet, okay? So the C001 bit has just turned on. Okay, this is my on threshold. So at 12 is when the event occurred. That's when the C001 bit turned on. Alright. Now let's do something else. Let's say that we're going on in the future here. If I go again 1, what do I get to? 13. What's the status of C001 bit? Still on, right? But now let's go ahead and change directions. Let's take the direction pin to high. Notice that my direction pin, I may have to relabel these. Again, this was direction. This was count. This was reset. And this was my C001 bit. Okay? My direction pin has now gone high. Okay, so now what does that mean, the next pulse I get? Yeah, it's going to decrement. So now the next pulse I get is going to do what to my current count?
Drop.
12. So now that should de-energize my C001 bit, right?
No.
Why not?
Because it's greater than or equal to 12. So
It's greater than or equal to 12, but also because my on threshold, remember my on threshold was set to 12. What was my off threshold set to?
1.
1. So at what point is this going to turn off?
0.
Never.
Yeah, it's not going to turn off even at 11, is it? It's not going to turn off until I get all the way back down to 0. Okay, so let's do it again. So C001 is still high. Let's do it again. What happens to my current count?
11.
It's down to 11, but the C001 bit is still on, right?
Yep.
Because I'm not less than the off threshold. So that's one kind of strange thing. If these were set equal, if it was 12 and 12, as soon as I got to 11, the C001 bit would have de-energized. And there may be times that that's what you want to happen. As an example, the parking ramp. The lot holds 1,000 cars. I get to 1,000 cars, I turn on the C001 bit, the C001 bit lights up a light at the entrance that says lot full. And maybe the C001 bit lights up that light using a normally open contact. Okay, there's my light, lot full. But maybe it also breaks the ability for my gate to be open. Maybe my entrance gate will not open when C001's there. But in this case, if I've got 1,000 cars in there, as soon as one car left, I would have spots now, right? So the lot would no longer be full. In that case, I would want my on threshold and my off threshold to be equal, exactly right. All right. So we know that we're decrementing. We know that if we continued to decrement all the way down to 0, it would turn off, right? But let's do this instead. Let's take that reset pin. And what if we make that, well, let me do it a little later in time. What if we make that reset pin high? What happens to my current value?
Restarts at 0.
Goes directly to 0. Because this would be my reset pin going high. As soon as my reset pin goes high, the C001 bit's going to do what?
So,
It's going to de-energize. And let's say at this point I also take my direction pin back to 0. But let's do something kind of strange here. Let's go over here and let's trigger in a pulse while that reset pin is high. What do you suppose is going to happen to that pulse?
it's going to be registered.
If the reset pin is high and I pulse, what's it going to do?
It's not going to.
Nothing.
Yeah, it's not going to register it. That's exactly right. It's going to ignore this pulse because the reset's being held high. It's saying, you know what? I'm being told to reset. That means plug a 0 in there and hold a 0 in there until I turn that reset pin off. At which point then, I could count another pulse, assuming my direction is low. Does that kind of make sense to you guys? Now, it's a lot to go on. There's lots of different combinations we can look at now. You know, we can have the count going, we can have the direction going, we can have the C001 bit going, we can have the reset going. Lots of different functions that you can use. The nice thing about the logo is, let's say you decide you don't want to use one of these functions. Okay, maybe you just want to be able to count up to 12, turn something on, and then have that reset it. You know, you could, as you're looking at it, you have the reset, the count, the direction, and then your parameter pin. You might only use 2 of the pins. And on the logo, that's okay to just leave this one pin empty. You can do that. On other PLCs, you're going to find out that it's going to say, well, you have to have something hooked up to every pin. Specifically on the S7224, it would call this a block without connection to an output because something's not connected up there. But the Logosoft logo and Logosoft itself will actually allow you to leave a pin blank. Okay? So maybe all I want to be able to do is count up to 12 and then run the packaging machine, then have the packaging machine reset the counter. Okay? Any questions on this so far? None. You guys comfortable on it? Pretty good? Alright. Let's erase that. There's one other counter that we talk about. But we don't necessarily use it a lot in here. And that's what we call an hours counter. My description for the hours counter is it's equivalent to an odometer in a car. So it tracks how long a machine has been running, or how long a process has been running, in hours. Similar to the way we track how many miles we have on our car. Why is it beneficial in your car to have an odometer?
Maintenance.
Maintenance is exactly it. That's the big thing right there. What do we do every 3,000 miles?
Change the oil.
Change oil. Maybe you do other stuff. What other stuff do we do? Maybe we do transmission service every, I don't know, 15 or 20,000 miles. If you look in the user manual for your car, it recommends service almost every 2,500 miles for something. Okay, maybe every 3,000 miles it recommends service for your oil. Maybe every 2,500 miles it recommends that you check the air pressure in your tires. Maybe every 20,000 miles it recommends that you flush your radiator. Maybe every 50,000 miles you need new tires. You know, what it does is it allows us to perform maintenance. So this is, it's good. For tracking maintenance, okay? That's what the hours counter is good for. All right? I'm gonna have to look at one inside Logosoft here real quick, just so I get your pins right. All right, there's a couple of things that go along with the hours counter. Here's what it looks like. And in this case, I'm gonna call it C002. But we already learned about, in timers, we learned that the counter address or the timer address is really insignificant, right? It just is a block number. It's just the block number on the screen. This hours counter could have just as easily been C001 or C010. It has a couple pins on it. A reset pin, an enable pin, an RAL, which is another reset pin. This just stands for reset all. Okay, so RAL is reset all, but you'll see it and you'll be like, what's RAL again? It's reset all is what it is. And then it has a blue pin. And what do we know about the blue pin? User. Yeah, this is my user parameter. The user parameter is the part that we have some special features on. We have maintenance interval, which is really your user parameter. MI. That's your maintenance interval. Okay. Once you have a maintenance interval, you also have an MN parameter, but it's not something you can set. It's I call it the time remaining, or hours remaining, however you want to put it. Okay. And then the OT, which is the operating time. So the maintenance interval, if you're setting up the logo for your car, let's say, the maintenance interval will be set to 3,000 miles. Okay? The time remaining would be taking the maintenance interval and subtracting out the operating time. So you could come up with an equation here. You could say that MN is equal to OT, or hold on, MI minus OT. There you go. Yep. Somebody already said it there for me. MI minus OT. The time remaining would be equal to what you've set up as the interval minus how long it's been operating. So if I have it set up for 3,000 miles, we could do this as an example. I have my maintenance interval set up for 3,000 miles, and then I say, okay, I've driven 100 miles. How many miles are remaining?
2,900.
At 2,900. We don't do miles though, remember. What we're doing is hours. So this could be maybe 3,000 hours of machine runtime before we need to change the oil on this piece of machinery. Okay, it could be 3,000 hours of machine runtime before I need to change an air filter on a piece of machinery. Or before I need to lubricate some bearings on this conveyor belt. I could have 3,000 hours. It might be 30,000 hours of runtime. Okay, it could be any number you want in there. Alright? The nice thing about this device though, we've kind of talked about how it works, the basics. And let me ask you one thing, because this comes up a lot, is let's say you don't remember. You don't want to go back and watch the video again. You remember a little bit about this counter. You remember that it's available, but you're out in industry and you don't exactly remember how to set it up. But you've got Logosoft open. What can you always do? You can simulate it. That's a good way to do it. Throw it in there. We know this is my hours counter, right? The other thing you could do is you could click on that function in the toolbar. You could click on the hours counter and hit a key. F1. And guess what F1's going to do? What's it going to bring up? What does F1 always bring up? Your help files. And the nice thing about most PLC software is that when I click on an instruction and I hit F1, what it does is it talks about the instruction and then it gives me a little bit of sample code. It's going to show you an example of a program using that instruction. So now if I ever want to go to use that instruction and I don't remember what was talked about in this class, I can just go in there, hit F1 and say, oh, that's how they use that. That's right. I remember that. And you can set it up in a similar fashion. Okay? Because you're not going to remember all these instructions. We're going to go over the course of the quarter, we're going to go over about 50 different instructions that we're going to use in that PLC. 50 different instructions out of probably 5,000 instructions. So you guys are just going to get just a very bare minimum, okay? But some of them are similar, okay? So we may talk about converting instructions for memory bits. We may talk about how to convert an integer to a real number, but converting an integer to a string is similar, okay? There's all kinds of stuff that's similar. So if you can figure out one, you can figure out most of them, and you can always go back to F1 if you have any trouble with any of them. All right, so let's talk about, let's say we've got this set up, right? And the enable starts me counting, right? The enable is what's gonna, let's define those over here actually. The enable basically starts the clock. It's like the start-stop button on your stopwatch, right? Except this stopwatch only works in hours. So the start-stop, I start counting hours. Boom. All right. That's what enable does. When the enable is true, it's counting. So if the enable is a 1, it's counting hours. And when the enable is a 0, it's stop. Okay? The reset. And I'm gonna have to look at these real quick here because these sometimes confuse me. Okay. The reset will only reset the C00X bit. Okay? So the reset, let's say that I've counted up a certain amount of hours. I can reset that bit. Once that C002 bit turns on, I can reset that bit using the reset. Let me just make sure here. Oh, okay, and there's one other thing it does reset too. It also resets the time remaining. It resets the C00 bit and the MN, which is time remaining, we talked about. Okay? There's a difference now between the reset and the reset all. Okay? The reset all resets everything. Resets the bit. It also resets MN, which is my time remaining, right? And it also resets OT, which is my operating time. Okay, this is a little confusing. We'll have to talk about this for a minute. So the enable is easy. When the enable is high, I'm counting hours. Boom, 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 boom. When I get, basically, when MN gets down to 0, that's when this bit is going to energize. Okay? When MN gets all the way down to 0, that's when this bit is going to energize. So by hitting the reset bit, I reset the amount of time remaining back to whatever my maintenance interval was. Okay, so if it was 3,000 hours, let's say I start up and I start counting down from 3,000 hours on MN. 29.99 all the way down to 1 hour. When I get down to 0 hours on MN, the bit, the C00X bit, will energize. Okay? If I hit the reset pin, then my C00 bit will de-energize and MN will go back to the maintenance interval value, 3,000 hours. So I'm back to where I'm running, right? The OT is kind of like, you know, we can go back to the odometer example. Your car has two different odometers, really, right? One of them, what do we call the one? Maybe like a trip gauge or something like that, or a trip odometer. The trip odometer might only go up to, let's say, 1,000 miles. Okay, what do we typically use that for?
Yes.
Yeah, I think the majority of us use it to be able to track our gas mileage. We reset it when we get gas, and then we go in there and we say, oh, we went 360 miles. You know, I filled up with 12 gallons of gas, so it's at 30 miles to the gallon, right? And then I reset it when I get that 12 gallons of gas, and I do it again. Or maybe I want to know how far it is from my house to Duluth. So I'm going to set it to 0 when I get on the road, and then when I get to Duluth, I make note of what it's at when I get to Duluth, so I know how far that trip was. Well, same thing here. Your MN is the value that we look at to energize the C00X bit. All right? And when we reset, we're going to reset the bit and we're going to reset MN. Okay? But we're not going to reset OT, because it might be important to us to perform that maintenance every 3,000 hours, but maybe we want to never reset OT. Because what can we track then if we never reset OT?
How many hours total the machine ran?
Yeah, the total machine runtime. Okay? And by tracking the total machine runtime, I can say, oh, you know what, we've done maintenance on this machine every 3,000 hours because that MN bit has insured it, right? But we know that this machine has been running for 200,000 hours. Why might it be important to know how long a machine has been running? What is it? Yeah, any other maintenance, or maybe I have a life expectancy on this machine. Maybe it's vitally important that I never have downtime. So maybe when I get to 200,000 hours of runtime, maybe that's the point at which we look at investing in another machine prior to this one having a hard failure. Okay? So the maintenance is going to get me to the 200,000 hours plus. But at 200,000 hours, maybe we look at setting up another one in parallel. So that way we have this one running as we're setting up the new machine. Maybe there's a certain life expectancy that we have for that machine. Now where can this come into play? This is really handy. Let's say that we're running this. I'm going to erase the stuff on the right here. Let's say that we're running this guy. And let's say that all he's doing is he's tracking, I don't know. He's tracking how long the machine's been running, right? So let's write a little bit of code. Okay? Let's just write a little bit of code to use this hours counter. Alright, in the hours counter, let's say that we have a system run bit. We have a stop, which might be I1. We have a start, maybe it's I2. I don't know if that's how they're wired on your boards, but that's how I'm going to do them. I have M1. What do I typically use M1 for?
Flag.
The flag. System run, that's what I like to hear. System run flag, very good. And then down here I have an M1 holding contact. Okay? And then down here, let's say we just want to track how long this machine has been running. Alright, so all I'm going to do is maybe M1 turns on the machine. This is going to be real simplistic. Q1 is my machine. Alright, hopefully that machine is more than just an output. Maybe it has sensors, maybe it has timers, maybe it has, robotic arms. It could have all kinds of stuff on it. It could be a huge assembly line, could be a punch press, could be a drill press, could be just a simple machine, could be a very complex machine. Okay? But then let's say I want to track how long that machine's been running. So I say, you know what, when Q1, when this machine is on, I want to feed one of the pins on my hours counter. And we're going to call this C001. Which pin am I feeding?
The enable?
The enable pin, very good. And let's say that I don't want to do a reset all ever, so I'm going to feed the reset pin with a push button. Let's call this I3. This will be my maintenance reset. And now I'm not going to necessarily draw them in the order that they show up on Logosoft. I'm going to draw them in the order that just makes sense for the way I'm setting it up, okay? But notice what I did do, so I don't screw it up when I go to program. What did I do to these pins? I labeled them. That way it doesn't confuse anyone later on. And let's say that my parameters on this, I'm going to do them in blue. Let's say my maintenance interval equals 1,000 hours. Alright? Now there's a couple of things I could do. I know that when I get to 1,000 hours, what is this C001 bit going to do? C001 bit is going to do what when the current count gets to 1,000 hours? It's going to energize. The C001 bit's going to energize. So one of the things I could do is I could come up here and say, you know what? When it gets to 1,000 hours, let's make it so that that hours counter kills system run. What does that ensure? Yeah,
They have to go in and
that means that they have to do the maintenance. They cannot start this machine up again until the maintenance is done. Okay, or really it just means that they have to hit the maintenance reset push button. But hopefully that means that the technician, maybe this maintenance reset push button isn't a push button. How could I protect it so only the guy that's doing the maintenance could reset this thing? Could be a key switch. A lot of times we'll do that on maintenance issues or on emergency stops or certain situations that are very vital. We'll make things a key lock. So this input now could be a key switch. So there's maybe only the maintenance staff has that key switch. So the operator of this machine says, hey, I've got a problem with the machine. The maintenance guy comes over and does it. But the problem with just killing it like this is, does the operator know why it died? He doesn't see this code, does he? So we're going to add one more thing to it. We're going to add, you guys may have already seen this, we're going to take that C001 bit and we're going to add a message text. And we haven't talked about this yet, but it's a special function. And because it's a block, all I'll say is it's a special function called message text. Okay? If you look in your special functions list of items over there, you'll find one that says message text. And what do we know about blocks? Blocks are always numbered sequential. So what do you suppose the block of this is? 002. So even there are no other special functions in this program, this block is going to get the next block address, which is SF002. And now what you'll find in the user parameters for a message text is exactly that. I can type things in. Maintenance required grease bearings. I could even put in some contact information. Contact, maybe I put in a phone number, 321-1234. So now, this message text is going to come up with that message. And where's that message going to display? Yeah, this is going to go right on the LCD. On the Logos LCD, that message text, as soon as this machine has been running for 1,000 hours, it's going to shut down. Cumulative 1,000 hours. I could run it for 2, shut it down for 10. Run it for 998, and now that equals 1,000, right? So as soon as it gets to a cumulative 1,000 hours, it's going to shut the machine down. It's going to say that on the screen. The technician's going to walk up to the machine and say, "Why aren't you running?" And the logo is going to display on the screen, "Maintenance required, grease bearings, contact this phone number." Now that operator can walk up to the phone, contact that number. The maintenance guy comes down, takes his little grease pot or his grease gun, and he actually greases those bearings real quick. And now he hits the key switch, and the operator can fire the machine up again. There's one thing about using the message text that's vitally important that you're going to discover in one of your next jobs here. The message text requires a flag output. Anytime you use this message text, the very next line, when you use it, should have a contact associated with it and what I call a message text flag. Okay? The reason why that is, this is very, very important. The reason why that is would I ever want to use a counter in a program if I didn't have any counter bits? Would there be any reason to use a counter if that counter wasn't controlling anything? Yeah, if this C001 wasn't here and this C001 wasn't here, there'd be no sense in having a C001. And the software will tell you that. It'll say, "Hey, wait a second. You've got a block in there that has no connection to any outputs in your program." It'll give you an error message. It'll say, "Blocks without connection to an output." And it'll say B001. It won't say C001. It just recognizes the block address, B001. So if I had no C001 contacts, it would give me that error message. Well, guess what it does on this block if I don't have a contact addressed to that block?
It gives you an error message.
It gives you the error message. Guess what that error message is? Blocks without a connection to an output. So you'll find that. So it'll happen to somebody in here on the performance exam. It'll happen to somebody. They'll have a blocks without connection to an output, and they'll sit there and spin their wheels and not figure out why they can't get their program to work. And Jeff will come over and you'll ask him and he'll say, "Ooh, you should be able to figure it out, troubleshoot it." And guess what he'll do? He'll either let you troubleshoot it to the point where your head's ready to explode and then show you and take some points away. You know, or if you don't want the points taken away, he'll just troubleshoot it till your head explodes. One of the two. But that's a general. I got to do one more quick counter example, and then we'll be done. Does this make sense to everybody? Yep. All right. One quick counter example. We're not using the hours counter. Just to get this in your notes too. I want to use the up-down counter real quick. And this one's not going to be a long one. This one will be really, really quick. Let's say this could be just a piece of code in your program. This isn't going to be the whole program. This might just be a piece of the code. Let's see. All right. So let's say I have an up-down counter. Let's say I have a C001. This is my up-down counter. Okay, and let's say that coming into the reset pin, I have something, I don't know what it is yet. I'm just going to run it into the reset pin because something eventually I want to reset this thing. Coming into the count pin, I know that I have a sensor. Maybe it's I3, this is my can sense. That comes into the count pin. And then I know I have a direction pin, but you know what? I'm not going to use the direction pin because I'm only going to count from 0 to 12. Okay? So over here, I'll say that my on threshold equals 12. My off threshold equals 1. Because all I'm going to do is count to 12, run the packaging machine. When the packaging machine is done running, I'm going to reset it, count to 12, run the packaging machine. Okay? And so there's my parameter. We know that our parameter actually goes to a green pin here somewhere, so I drew it in there. Now when this gets to 12, how do I turn the machine on if this is an up-down counter? So I have this machine. This is my, maybe this is my packaging motor. Okay, maybe it's Q1. I want that packaging motor to turn on when this gets to 12.
Normally open C001.
You got it. Normally open C001. When my can count, I can even put a comment on this. This would be my can count. When my can count, and rule of thumb, all contacts, all coils should have a comment. Okay, all boxes should have a comment. When my can count gets to 12, the packaging motor runs. And then maybe what we do is we say, okay, let's track how long that motor's been running. Maybe, really in real life we're not going to time how long the packaging motor is going to run. Okay, for simulation purposes I might say, oh, let's run the packaging motor for 5 seconds to watch it loop back in. So we see this nice continuous loop where it runs, shuts off, and we start counting cans again. Runs, shuts off, start counting cans again. In real life, what determines how long the packaging motor is going to run?
Human when it's done.
Not necessarily human, but when it's done. How do I determine when the packaging motor is done? Sensors. Yeah, so, if I've got this nice big box here, okay, this nice big box might be what my packaging motor works on. And what it might be is it might be when all of these flaps are sensed to be shut and taped. Then my packaging is complete. And I can use a sensor for anything. Okay, I can use a sensor, if I'm in the pharmaceutical industry, I can use a sensor to count how many tablets go in the bottle. I can use a sensor to tell when the packaging machine has put the cap on the bottle correctly. I can use a sensor to make sure the label is placed on the bottle correctly. And so those things are going to, typically run automatic, right? These are automated systems. The only time the human has to touch any of these systems, really, is when there's a flaw. Okay, so let's say that this box is sensed to be put together wrong. What we do is we have a conveyor belt. Okay, normally this conveyor belt is running like this, right? There's boxes coming down like crazy, and everything's coming down that line. At some point, let's say one of those boxes does not meet a quality specification. What the machine can automatically do is it can kick it out. So normally everything's going to go down here the normal route. Okay? And then something that does not meet QA or does not meet the quality specification, so I put a Q with a not over it, Q not, what that'll do is the machine will maybe take a big solenoid or maybe a robotic arm or something, and it'll kick it out and this will slide down here. Now guess who's working over here? That's the human, right? That's the guy that says, ooh, something's wrong. Let's figure out why this one didn't get packaged up right. If I'm getting spit out 10 of them in a row, the human's going to stop the line, okay? If I just get spit out one because maybe the cardboard, was not cut correctly or something, the flaps went to fold in and one of them wasn't cut where it needed to be to fold in. That was just the cardboard manufacturer screwed up, right? Not us. That was the materials that we're using that were screwed up. So I just, take my utility knife and manually close it up and seal it up and send it on down the line. Okay. So, but in this case, we're not gonna get that deep into the process. For our automated systems guys, that's what you guys are thriving for. That's where you guys really come into play. Okay. So in this case, we're just gonna time it just to make things work. So if I wanted to time it, I might use an on delay timer. And I know there's an enable pin on that on delay timer. Okay. And I know there's also a blue pin. What's a blue pin? User parameter. And in this case, let's just say that on delay timer runs for 5 seconds. Okay. So when the packaging motor has been running for 5 seconds, I want the packaging motor to shut off, and I want the counter to reset. And what's the address of this guy? C002, because it's the next available block address. What can I do to make everything work without adding anything else?
Is that T002?
Oh, yeah, very good. Yeah, it's definitely not C002. It's a timer, okay? It's not a delay timer, it's T002. And what do I do to make the whole system work now and see it loop?
you need to label that T002 up top.
You got it. And you're done. Because normally what's going to happen here, let's look at this. I start counting cans. Let's say, this logo is just sitting by itself next to the conveyor belt, okay? And the conveyor belt might be running manually. This logo might be sending signals back to the conveyor belt, so maybe when the packaging motor is running, maybe the conveyor belt shuts down for a moment so it can keep up. But we're just looking at a small piece of the process. So the cans are coming down the conveyor belt. We're counting the cans, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When I get to 12, what does this bit do? Turns on, the motor turns on. When the motor turns on, what does this timer start doing? It starts timing. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. When I get to 5 seconds, what happens?
Resets.
T002 is going to close. It's going to reset the counter. When the counter resets, what happens to this bit?
Opens.
Opens. When that opens, this opens. When this opens, the timer opens. And because it's a non-retentive timer, what is this timer going to do when I lose power to it?
Stop.
It's going to stop. It's going to reset. It's going to go back to 0. It's not going to retain its time. If this was a TONR, in this case it's a TON, an on-delay timer. If this was a TONR, I would have another pin here. What would that pin be labeled?
Reset.
Reset. I'd have to manually reset it. But we know with the TON, it's going to reset just upon losing the enable signal. Does this work? Has this created an infinite loop? If I run cans past that sensor, is it going to turn the motor on and run it for 5 seconds every time? Is it completely automated? No. Because there's no way to ensure that a 5-second run of a motor is going to ensure that that package is sealed up correctly. So this is just a snippet, it's just a little tiny snapshot of a program that might be 1,000 runs long. But it's just one piece of it. So, any questions about anything we covered today? Does it make sense? That's it.